Hello everyone and welcome to our new video. This is the third part of the Jenkins dynamic slaves creation in the Kubernetes cluster. So if you have not gone through our previous video, I will suggest you to first go through our initial two parts in which we have discussed about the Jenkins slave on Kubernetes, how you can create the dynamic slaves on Kubernetes, and in the second part we have covered about the Minikube and the Docker on the Kubernetes cluster installation along with the kubectl to interact with the Kubernetes cluster. Now in this part we are going to proceed on the Jenkins installation. Okay, so we are going to install the Jenkins and configure the dynamic slaves within the cluster that we have created. Okay, now before we start on the Jenkins installation, you need to understand that we are going to create a Nfs Mount. Okay, so let me share my screen. All right, so I have created this instance. This instance we have created in the previous video. So it already has the Minikube installed on it. Okay, so Minikube has been installed. Now since we are having the single instance, so I am going to create the Nfs Mount. Now why do we need an Nfs? So Nfs is basically a shared which can be used across the multiple servers. Now because you are configuring Jenkins to run on Kubernetes, so a pod can come up and go down anytime. So you are not having the control on it. But you don't want to lose the configuration of the Jenkins that you have created. So in order for us to make this data available persistently, we are going to create an Nfs Mount, and we are going to export this Nfs mount that we are going to create. Then we are going to create a persistent volume and claim this volume, and when we deploy the Jenkins inside the Kubernetes, at that point we are going to use that persistent volume claim. So that being said, let's create this Nfs Mount. Now in order to create the Nfs, you need to first install the Nfs server on your system. So let me switch to the root user. Okay, all right, so I have become the root now, and I'm going to install the Nfs server first of all. So I will say apt install -y nfs underscore nfs -server. Now if you are doing this on a multi-host, that is more than one host, then you can create a separate host for the Nfs server and export that to the other host where they can mount it. Okay, so all the servers should be within the same network that is reachable to each other if you want to share the Nfs volume that you are creating. All right, so let's install the Nfs server. So Nfs server is installing right now. Now once you have installed the Nfs server, go ahead and create a /data directory. This is the directory which we will be exporting, and we will be allowing the permission to write on this mount across the Jenkins server. Okay, so this has been installed. So Nfs has been installed now. Now next we are going to create a /data directory. All right, now once you have created the /data directory, go ahead and uh, assign the permission. So we are going to change the permission to 777 in our case, so that everyone has read-write access to this directory. All right, we have given the 777 permission. Now once you have done this, go ahead and you will have to export this directory /data directory. So go ahead, create a file /etc exports, and under this exports directory which is used by the Nfs server, just mention about the /data star and read write sync, no subtree check, and insecure. So again, since this is our own network and it's in a private subnet, so even if we are not using the insecure, since it's a private subnet, so that shouldn't be of any concern. All right, so let's save this now. All right, we have saved the Nfs configuration. Now go ahead and restart to make it effective. So we can say systemctl restart nfs -server nfs -server .service. This is going to restart the Nfs server. Now once it has been restarted, you can verify the status of the Nfs server. All right, so it's checking the status right now. So the NFS service is running right now. All right, now if you want to verify if the directory has been successfully exported so that it can be mounted on the other server, you can run the export fs command, which is going to show you the status of the volume being exported. Here it shows that it's exporting the /data volume, which is what we want. Now we are going to use this NFS Mount and we are going to create a persistent volume using this NFS module that we have just installed. So we will be creating a persistent volume over this NFS Mount and we will be using this inside our Kubernetes master server. All right, so next we are going to create a persistent volume -nfs.yaml. Now all the YAML configuration which we are going to use to run over the Kubernetes, this is available inside our GitHub repository. So I have shown this GitHub repository in our last video. I will be updating a link to our GitHub repository inside the description so that you can go ahead and replicate the same in your environment with little changes inside the YAML configuration, but all the configuration which I'm going to use, those will be available inside that GitHub repository. So don't forget to check that GitHub repository. All right, now let's create this persistent volume of NFS. So let me just create the persistent volume and then I'm going to explain this persistent volume that I'm creating right now. So let me just update the configuration. All right, this is the configuration. Now if you look here, we are using the API version which is hard coded. So we are using the v1 for it. Kind, we are creating a persistent volume. So basically whatever resource that you are going to create inside the Kubernetes, that comes under the kind. Now metadata is more information about this kind. So basically more information about the persistent volume. So the name of the persistent volume is pv nfs pv1, and we are going to create a separate namespace for running the Jenkins, which is called Jenkins. This Jenkins namespace will exclusively be available only to the Jenkins to manage its build and deployment. Now we have assigned a label type local to this persistent volume, and specification, we are using a storage class as manual, capacity as 20 GB. Access mode, we are using the read write many, and we are using the NFS server. And since the NFS, you need to provide the NFS IP or the host name here. Make sure that the host name, if you are using a host name, that should be resolvable. We have already performed this step. So this Jenkins Unix Cloud Fusion.n should resolve to this server IP itself. So again, we have already made these changes. Path/data, this is the directory that we have exported. All right, now you can save this. Let's save this. So now once you have saved this, we can go ahead and create this persistent volume. For creating the persistent volume using NFS, run kubectl create command -f and the file name. This is going to create the persistent volume. All right, now basically the kubectl command won't be able to run from the root user because it doesn't have the permission. So let's switch to the vagrant user and let's run this command as a vagrant user. Create -f pv -nfs.yaml. All right, I think the directory is basically changed. Let's verify where we have created this. This has been created under /root directory. So I will be moving this file to the home directory of the vagrant user. And I'm also going to change the ownership of this to the vagrant user. Make sure that you also do it in order to run this YAML configuration. Now once we have done it, we can safely switch to the vagrant user or any other user that you want and just run this using the kubectl. So I will be running this using the kubectl configuration. Now once I run this, it should create the persistent volume. All right, so persistent volume has been created. Now, once you create the persistent volume inside the Kubernetes, you need to claim that persistent volume. So next, I'm going to actually claim this persistent volume that I have just created. For that, I will have to again create a persistent volume claim. So I will be creating a file, persistent volume claim, that is pvc hyphen nfs dot yaml, and we are this time going to claim this persistent volume that we have just created. Once we claim it, then we can use it inside our deployment. So if we look at the configuration file, API version, which is hard coded, it's v1. Kind, it's a persistent volume claim that we are creating. Metadata, name of the persistent volume claim, that is pv-nfs pv1. If you want to create more, you can create additional persistent volumes as well. Namespace, it is we already created this inside a separate namespace called Jenkins. Specification, so storage class is manual. Access mode, read write many. Resources, request, we are basically using the storage of 20 gib. So let's save this. All right, now once you have created the persistent volume claim configuration, you need to create a Jenkins namespace. So you can create a namespace using kubectl create namespace command, and you can create a Jenkins namespace. It says Jenkins namespace created. Okay, so it has been successfully created. Now once you have done this, go ahead and run your persistent volume claim configuration that you created in previous step. So we can say kubectl create -f and persistent volume claim nfs. So once you run this command, it's going to create a persistent volume claim. Now once the persistent volume claim has been created, okay, make sure that you install nfs common package on all the server where this pod can be created. So you should be having this nfs common package from apt installed on all the worker node. Better to make it a part of your image. So what you can do is you can say apt install nfs hyphen common hyphen y. Now this command needs to be run from the root user. So better to install it from the root user, or you can use the sudo as well. So we have already installed the nfs. At that time nfs common has also installed. After this, we are going to create a deployment. So we are going to create a deployment from the vagrant user only, that is having the access to the Kubernetes. So next, I'm going to create a Jenkins deployment file, which is actually going to deploy the Jenkins inside the Kubernetes. So I can say Jenkins-deployment.yaml. Now I'm going to deploy the Jenkins using my Jenkins deployment file. Okay, so let me create the Jenkins deployment configuration, then I'm going to explain it. All right, let's go through this. Now there is few changes I would like to do. So this lifestyle will be coming later. At that time I will be explaining you. For now, this is the configuration. So if you look here, API version apps v1, which is a hard-coded configuration. Okay. Next, we are creating a deployment this time. So kind is deployment. Metadata, that is more information about the deployment. So we are naming our deployment as Jenkins. It will be done inside the namespace Jenkins. We in the specification, that is about the specification about our deployment. So we want to create single pod. Okay. And we are using the selector to match the labels, and labels are app equal to Jenkins. It will help us identify the Jenkins pod. Next, we are going to use a template, and the metadata about the template is using the labels app Jenkins. Then we can specify the specification of the volume and the container. So in the specification, the volumes, we are making a use of Jenkins-home, and we are making a claim over the persistent volume claim that we have created. Specify the claim name that you have already created in the previous step. Next, we are going to specify about the containers. So we want to run inside the pod a Jenkins container, and the image that we want to use is of an LTS, that is a long-term supported image from the Jenkins. Okay. Next, we are passing the environment variable. So here we are passing in Java optional, and we have basically created a value where we are setting up the wizard to false. Okay, so it's not going to run the setup wizard. Then we are specifying the ports. Inside this, we have specified the HTTP port, which will be running on port number 8080, and JNLP port used by the Jenkins internally. So it will be running on the port number 50,000. All right, so that's all the configuration that you need to create for now. Just save this. All right, we have created the Jenkins configuration now. So we can do this deployment. For doing the Jenkins deployment, run kubectl create -f Jenkins -deployment.yaml. So it says that the Jenkins deployment has been created. Okay. Now, once you have done the Jenkins deployment, you need to create a Jenkins service to expose the Jenkins. Now we are going to use the node port service in order to expose the Jenkins and basically access it. So next we are going to create a Jenkins service. So let's create the Jenkins service now. We can say vim Jenkins -service.yaml. Okay, and we are going to define the service now. Let's create the Jenkins service. So if you take a look, API version is v1. Kind, this time we are going to create a service. Metadata about the service, name of the service is Jenkins. We are going to create a service inside the Jenkins namespace. Specification, we are going to create a service of type node port. Then inside the ports, we are going to use a port 8080 on which Jenkins run. Target port is also 8080 on which Jenkins run. Selector, we are using the app equal to Jenkins. So we have used those selector. It will be checking the pod which is having those labels to it, and then it will be applying this. It will be enrolling that pod with the service. All right, let's save this and let's go ahead and create our Jenkins service. So in order to create the Jenkins service, just run kubectl create -f and Jenkins -service.yaml. Now, once you run this, it's going to create a Jenkins service. If you want to check the details about the service and the pod that has been created, you can go ahead and run kubectl get all command inside the namespace Jenkins. So if I do this, you will see that it has created the Jenkins service over the cluster IP. This is the cluster IP and this is the port. Basically, it has exposed it over the 31,776 port, and so the deployment has been completed. Now, if you want to expose this, you can get your cluster information at kubectl cluster-info. Okay, so it will print the information. So now you can expose it over the 192, but there is one problem, that this 192 IP belongs to the private subnet. Now, if you are having a VPN configured in your organization, you can whitelist that and connect it and directly access it in your browser. But we are not having the VPN configured, and so we are going to use Jenkins. We are going to use, in order to access Jenkins, we are going to use the Nginx. And basically, we are going to use the proxy feature of Nginx. So in a way, we are going to access the server public IP, and we are going to say that whenever a request comes for the directly over the server at port number 80, just forward it to this private IP at the port number 31776. It's going to proxy that request on this port number, and the connection should be established, and we should be able to open the Jenkins dashboard in the browser itself. Okay, so next we are going to install the Nginx. That part we are going to cover in our next video, as this video has already gone little long. So that part I will be covering in my next video. All right, thanks everyone for viewing this, and I will catch you in the next video. Thank you.